Hey folks, in this video I want to look at implementing the pop operation for a stack using a linked list. So at the start of the day we have of course a stack, and the stack contains some sort of a linked list. This linked list has several things in it. For example, up here I have it containing 5, 3, 7, and 2, right? 4 things. So let's try, before we do any code, seeing how it would look if we wanted to pop a node from this linked list. So I have 4 elements. What happens? Well, I already know, right, that the list exists and that I have a variable called top which looks at the topmost thing, okay? So what I'm going to do first is actually maybe a little unintuitive, but I'm going to basically just create another variable that knows about the topmost thing, right? So that's what I have in my picture here. Notice that I have basically a new variable appearing that is pointing at 5, right? So it's a variable that knows about this topmost thing. That's going to be kind of our first step. Now, this is maybe interesting, right, because it's not clear why we're doing this, but you'll see in a second. Okay, this is the first thing we want to do, right? Our goal is just to pop, to remove one element from this list. The next thing is we'll update top, right? And this is where we need to have that second step already completed. Top, instead of looking at 5, is now going to be looking at number 3, right? So it moves forward, right? This is kind of our step 2. We are advancing the pointer, we're advancing the reference, we're moving it forward, and we're basically forgetting about that first node, right? Top now thinks that the topmost element is the number 3. It doesn't know anymore that the topmost element is 5, right? We've moved it forward by 1. That's what it thinks is the new top. Now, if you think about it, this is why we need to save that reference earlier. If we don't save that reference earlier, I wouldn't know anything about what that topmost element was, right? So I would forget about 5. I would forget about 5 ever even existing, right? There would be no arrows leading to it, so there would be no way for me to access it, no way for me to get to it, right? And that would be a problem because in pop, I want to return that topmost element. I don't want to just remove it from the list. I got to return what it stores as well, right? So I need to have saved that thing before. Okay, so I have these two already in kind of existence. So I saved a reference to the top one to the topmost node. Then I've updated top to be the newer top, right? And I'm almost done by then. And this is, I guess I can call it step 3. By this point, basically my list is updated, right? I've removed the thing that I wanted to remove. The only little bit of work to do is basically like open up that node, right? So a node is this thing we removed from the list, but we want to open up the list. They want to open up that list node and basically take out the element that's inside of it and then return that, right? So we don't want to return to the user this box, right? We want to return the thing inside of the box, right? That's what we want to do. All right, so that's the 3 basic steps here, right? This is how we kind of add, or this is how we remove a node, right, from the front of a list. All right, so we have this. Let's take a look at the actual code for it. So linked stack. So again, the code isn't too complicated. So let's take a look at pop, right? The kind of the full version down here. Now the first 2 lines are maybe familiar, and I guess it carries across to both peak and pop. These are our lines basically to check, do we have anything to work with, right? If we don't have anything being stored in our stack, then it doesn't really make any sense for us to do a pop or a peak. Really, we should throw an exception to indicate to the outside world that, hey, this isn't going to be happening. So we'll start off with that, pretty much the same as the array-based implementation. So middle part here. So we have basically our first line here, which is item type element equal top.getElement. So that's us basically reaching inside that topmost node and taking out something and writing it down, right? So this is maybe us storing that 5 or whatever it was, right, that was inside that top node. So this is a little bit maybe like steps 1/3 combined on the previous slide. You could do them in a different order as well, right? But I was trying to make the code fit in the slide, so I kind of combined them in one step here, right? So item type of element equals top.getElement, right? So reach that into that topmost node, right? It's called top. Take out something, save it. All right, now we have top equal top.getNext. What that's doing, right, is moving forward our arrow, right? So initially top is looking at that first element in that list. We do top equal top.next. That moves us forward, right? So from one element, right, we step forward and go to the next element, right? And then the next element, right, this gets called over and over again. We move forward by 1. So this is our step 2. The last step there, right, it's here in the code is basically n minus minus. That's to decrement. That's to basically record that, oh, hey, you've removed one thing, right? So you're 1 element less than you started with. All right, and at the finally end, right, we've basically taken out an element, we've updated the size, then we can return the thing that we took out. All right, so hopefully it's not too bad. That's our pop implementation here. Up top, you can see basically peak. Peak is basically a short bit of this, right? Peak is just implemented by saying top.getElement, right? So go to the topmost element, see what's inside it, right? Just look at the top, at the contents of that topmost node. All right, so there you have it. That's our implementation of the pop operation for a link-based stack.